Pressure, just force divided by area, simple, right? Then why do engineers use PSI? Doctors talk in millimeters of mercury. Scientists prefer pascals, and deep sea divers measure pressure into bars. If pressure is one thing, why so many ways to measure it? Before we explore the many pressure units, let's understand what pressure actually is. In simple terms, pressure is force divided by area. But at the microscopic level, it's much more alive. It's the constant bombardment of tiny molecules slamming into surfaces. Each time a molecule hits a wall, it transfers a bit of momentum. The more frequent and forceful these collisions are, the higher the pressure. So, pressure isn't just a number, it's the invisible rhythm of countless molecular impacts playing out each every second around us. In 1643, Italian scientist Evangelista Torricelli was trying to answer a strange question. Does air have weight? He took a long glass tube, filled it completely with mercury, sealed one end, then flipped it upside down into a dish, also filled with mercury. But something curious happened. Some mercury flowed out, but not all. A column of mercury stayed suspended, about 760 millimeters high. It didn't fall. Torricelli realized something no one else had. The air itself was pushing down on the mercury in the dish, holding it up. And just like that, he had discovered atmospheric pressure. That height, 760 millimeters, became a new unit of pressure. We call it 1 atmosphere or 760 millimeter of mercury. But millimeters of mercury had one flaw. It was based on the physical height of a fluid column. Great for labs, not so great for equations. So scientists needed something more abstract, something cleaner, something that didn't depend on gravity, glass tubes, or liquid. And out of that need came the TAW. Named in honor of Evangelista Torricelli, the man who first revealed that air could push. One TAW is defined as exactly the pressure needed to support 1 millimeter of mercury. Same scale, different purpose. While a millimeter of mercury lived in clinics and weather stations, TAW became the unit of choice in vacuum chambers, particle accelerators, and quantum labs. A tribute to the 17th century genius used to measure the tiniest pressure of the modern world. Before we gave it a name, we already understood it. Pressure was simply force over area. Push harder, more pressure. Spread that force over a wider surface, less pressure. As Newton's law gained traction in 17th century, scientists started thinking in forces and areas. But no formal unit existed. Engineers and physicists just used force per area in calculations. By the 1800s, Newton per square meter became the go-to representation in physics and engineering. But there was a problem. Using newtons per square meter was technically correct, but practically, it was a mess. Normal air pressure around 100,000 newton per square meter. That's a lot of zeros. Clunky in conversation, confusing in calculation, and far from intuitive. Enter Sir William Napier Shaw, a British meteorologist with a simple idea. In 1909, he proposed a new unit of atmospheric pressure. He called it the bar, from the Greek word baros, meaning weight. It made sense. 1 bar was equal to 100,000 pascals, perfectly matching average atmospheric pressure at sea level. 1 bar equals 100,000 pascals. It was clean, round, convenient. No more scientific notation and perfect for weather reports, aviation, and even deep sea diving. From storm warnings to submarine gauges, the bar made pressure make sense. By the 20th century, pressure was everywhere in labs, in factories, in medicine, in machines. But each field had its own unit bar, millimeters of mercury, atmospheres, psi. Confusion reigned. Science needed order. Something universal, something rooted in physics. So, in 1971, the world's top scientists and meteorologists came together at the 17th General Conference of Weights and Measures. They made a decision that could change how pressure is measured. Pressure be standardized in SI system, and so they chose the Pascal, named after Blaise Pascal, the brilliant 17th century French mathematician who explored the mysteries of vacuum, air, and pressure centuries before. 1 Pascal equals 1 Newton per square meter. The simplest, most logical form. force over area. The core idea, now with the name of honored the man who helped us understand it. The Pascal became official. Science had its standard. Atmosphere. Back in the 1700s, scientists needed a standard for air pressure. So they defined one atmosphere as the pressure at sea level. About the force needed to hold up a mercury column 760 mm high. It became the global reference for everything from weather to steam engines. Pounds per square inch. Then came the Industrial Revolution in the West. Engineers in the US needed a practical unit. Entered PSI, pounds per square inch. Force in pounds, spread over inches. Perfect for engines, tires, and hydraulic systems. Inches of mercury. Before electronics, pilots and weathermen used barometers with mercury. Inches of mercury gave a direct readout of atmospheric pressure. It's still used in aviation and weather today. Kilogram force per square centimeter. This one is literal. Imagine 1 kilogram pressing on a square centimeter. That's 1 kilogram per force per square centimeter, used in mechanical and hydraulic system before SI units took over. Technical atmosphere. In Europe, especially the USSR engineers defined another unit, the technical atmosphere. It was based on the pressure exerted by 1 kilogram force per square centimeter. They called it at a bridge between the metric world and mechanical forces. Barry. Need something tiny? Enter the Barry, the CGS unit. 1 Barry is just zero point 0.1 Pascal, ideal for low pressure systems like vacuum, research, or subtle airflow. And before we wrap up, here is a quick list of some other pressure units you might come across. If you learned something new, give it a like and subscribe for more videos. See you in the next one.